Okay, so again, mukbang na naman tayo ng problems, past board exam problems about thermodynamics. I have here indefinite amount of problems. Isolve natin isa-isa. Wala akong notes ha. Ayan, makita niyo, wala. So, paano yan? Tara na. Mag-enjoy tayo sa pagsosolve ng ating mga problema. Diba? Problema. Ito ang problema na kaya nating solban. Pero ang pera, wala. Diba? Hirap. So, for number 1, helium is compressed isothermally from 14.7 psia and 68 degrees Fahrenheit. The compression ratio is 4. Compression ratio. Okay. Calculate the change in entropy of the gas given that R is helium. Helium pala siya, no? Now, isothermal, ibig sabihin that is constant temperature. Oh, getting back with your thermodynamics, if you have isothermal process, gamitin mo yung combined gas law. At the combined gas law, you have P1 V1 over T1 equal to P2 V2 over T2. Ngayon, lakihan natin pala yung ating font. Ayan. Now, constant ang temperature, ibig sabihin we can cancel out yung temperature. So, we have P1 V1 equal to P2 V2. Now, anong sinasabi niya dito sa compression ratio? Now, pagsamahin natin yung parehas. Cross-multiply natin. So, P2 over P1 is equal to V1 over V2. Where V1 is the maximum maximum and V2 is the minimum. Okay? Now, this is now your compression ratio. Ayan. For isothermal process, anong hinahanap dyan? The change in entropy. Oy, mahirap ba yan? Hindi mahirap yan. Kasi ang isothermal, pare-pareho lang po ng formula. From work net to steady flow, iisa lang ang formula niyan. Pwedeng P1 V1, okay? Work net tuloy. Work non-flow is equal to work steady flow. Now, that is equal to P1 V1 ln of the compression ratio, V1 over V2. Or baliktad, pwede namang V2 over V1. Pwede rin tong yung P1 V1, going back, PV is equal to MRT. Diba? For noble and ideal gases, kinagamit natin yung ideal gas law. If PV is equal to MRT, then it is interchangeable with MRT. 1 ln of V2 over V1. Yan. Pwede yan. Okay? So, let us go with the change in entropy. Ayan, change in entropy, basic lang yan. The change in entropy is simply given by this formula, MR ln of the ratio. Yan. So, masasolve na natin yung kanyang change in entropy. O, specific change in entropy yan eh. Yung mass, wala tayo. Meron tayong isothermally from, you have MR. R. Okay, R. Tapos meron tayong T. Okay? R na lang, yung R. That is 0.4961. BTU per pound degree Rankine. Loan nung compression ratio. O, ganun lang kadali yun. So, the compression ratio is 4. And the answer will be calculating 0.4961 times ln of 4. So, the value is 0.4 decimal places, 6877 BTU per pound degree Rankine. Basic pa yan for problem 1. So, problem number 2. Polytropic process. Yan naman ang problema natin. Polytropic process. In your polytropic process, you are given this equation. So, P1 V1 raised to N, that is the polytropic constant, yung N na yan, equal to P2 V2 raised to N. Polytropic constant pa. Now, anong hinihingi sa'yo dito? During the polytropic process of an ideal gas, the state changes from 138 kPa and 5 degrees Celsius to 827 kPa and 171 degrees Celsius. Take note, ang temperature and pressure should always be at what value? Absolute value. Now, you are ought to find the value of N. Mahirap ba? Madali. Madali lang yan. Papakita ko sa inyo kung paano. So, you are given temperature, di ba? Polytropic. Polytropic, kapareho lang yan. Kapareho lang yan po ng isentropic formula. Yung T2, P2. T1, T2, T1 equal to P2 over P1 raised to N minus 1 over N equal to, baliktad naman to, V1 over V2 raised to N minus 1. Ang meron tayong value sa temperatures and pressures. Okay, algebraically, pwede natin yang isolve yung N. Ganito, mag-algebra po tayo. Unahin na natin si P at T. P and T. So, T muna, T2. 171 plus 273. Cancel mo na yung unit. Kasi makakancel naman yan. Pareho lang naman silang denominator. So, 5 plus 273. Oh, good to go. So, P2 over P1. P2 is 827 divided by 138. And then raised to N minus 1 over N. Ang problema dito, pwede na nating simplify ito. Let us simplify this expression. This one and this one. I will store this value at A and I will store this value at B. Okay, let's proceed. Now, calculate muna natin using our calculators. So, 171 plus 273 divided by 5 plus 273. So, we store this value at A. Yung nasa loob naman, i-store natin yung value niya kay B. 827 divided by 1, 3, and 8. And then, store natin yung value niya kay B. Now, we have the values for A and B. Raised to N minus 1 over N. Now, how will you take this exponent para maging hindi siya exponent? Now, all you have to do is to multiply it or gawin mong logarithmic both sides. Okay. Para maibaba natin to. So, ln of A equal to N minus 1 over N equal to. So, ln of B. Now, we can divide both sides by ln of B. So, N minus 1 divided by N is equal to ln of the value of A divided by ln of B. Na-store na natin yung value niya. Proceed tayo. So, N minus 1 over N equal to, ito, pwede ko itong i-store yung value niya ay C. Okay? So, ln, ln of alpha A, ln alpha A, divided by ln of alpha B. Yung mga values na yan. And then, you store it with C. Now, meron ka ng value. I-multiply mo na. N minus 1 equal to N tapos yung value ni C. O, pagsamahin natin yung may N. So, N minus C, N equal to 1. Ngayon, i-factor out natin yung N. N is equal to, yun N, 1 minus C equal to 1. Okay, para makuha natin N, divide natin to ng 1 minus C. So, N will be equal to 1 over 1 minus C. The value of C. So, 1, tapos 1 minus alpha C. The answer will be 1.3541. Very basic lang. Algebra lang yan. How about problem number 3? The thermal efficiency of a particular engine operating on an ideal cycle is 35% efficiency. That is equal to, pwedeng ganito. Okay, pwedeng ganito. You are given yung efficiency of all the power cycles, lahat naman yan pare-parehas. The network of the system divided by the total heat added to the system. Pwede rin naman natin basihan yung kanilang heats. So, 1 minus QR over QA. Pwede rin naman kapag Carnot. So, 1 minus temperature low minus divide by temperature high. Ganun lang yon. Now, anong hinahanap dito? Calculate the heat supplied per 120 watt-hour work developed in kilojoule. Mahirap ba to? Actually, hindi. Meron ka ng efficiency. Ang hinahanap mo na lang is QA. O, hanapin natin. So, efficiency is equal to work net divide by QA. Ang hinahanap is work net. O, di ibig sabihin, work net, hindi, heat supplied pala. Heat supplied ang tinatanong. So, QA is equal to work net divide by E. O, so QA is equal to, okay, this is 35. So, 1,200 watt hour divide by 0.35. Ang kailangan nating unit is kilojoules. Ngayon, yung watt kasi, so 1 watt, 1 joule every second. Yung hour, pwede nating simplify. You have 1 hour every 3,600 seconds. Yung joule, pwede natin gawing 1,000 joule every 1 kilojoule. So, tapos na yung ating paghihirap. Masosolve na natin siya. We cancel all the same units. Yung watt, si joule, si second, si hour, si hour. Ang lumabas is kilojoules lang. We can now calculate for QA. QA is 1,200 times 3,600 divide by 0.35 times 1,000. Very basic lang. So that is 12342. 0.8571 kilojoules. Okay? Number 4, tignan natin. The maximum thermal efficiency possible for a power cycle operating between. So, meron kang T-high and T-low. This is T-high. This is T-low. Yung sinasabi ko kanina. So, the efficiency is equal to 1 minus TL over TH. Anong formula to for Carnot power cycle? So, E is equal to 1 minus, kailangan to naka-absolute form yung inyong temperature. So, T-low is 225 plus 460 divide by 1,200 plus 460. Multiply to 100%. Calculate. 1 minus 225 plus 460. Tapos, 1,200 plus 460. Multiply mo ng 100%. So, the answer is 58.7349. That is for the efficiency of the cycle. Number 5, a steam condenser receives 10 kilogram per second of steam. So, meron kang mass flow rate ng steam. And then, with an enthalpy, ito yung nare-receive niya, of 2570 kilojoule per kilogram. The steam condenses into a liquid and leaves with an enthalpy of. So, ito yung condenser mo. Papasok dito yung steam mo. May heat exchange dyan. Okay? May QR na lalabas. So, ito yung H1, ito yung H2. Okay? Now, yung temperature of the cooling water, lalabas dyan. Okay? This is temperature low, this is temperature high. Papasok sa dyan, ay papasok dito yung water mo as low, lalabas na high. The temperature low is 13 degrees Celsius, lalabas siyang 24 degrees Celsius. Calculate the cooling water flow rate. Okay, ganito yan. Yung heat that is added by the steam will be equal to the heat that is absorbed by your cooling water. Now, itong heat na to is actually yung mass flow rate of the steam multiplied to the changes in enthalpy. And then, syempre ito is the heat that is added to the cooling water. So that is mass of the cooling water, tapos yung Cp of the cooling water multiplied to the change in the temperature of the cooling water. Now, we are ought to find the mass of the cooling water. We simplify. So mass of the cooling water is equal to Ms multiplied to the change in enthalpy divided by Cp of water multiplied to the change in temperature. So, calculate the value. M is 10 kilogram per second. H2 is 2570 minus 160 kilojoule every kilogram. Divide by Cp of water is 4.187 kilojoule per kilogram. Degree Kelvin, yung iba ginagawa 4.186, may karugtong pa yon. Multiplied to the change in temperature, that is 24 minus 13. Celsius degree kasi change in temperature na yan. So we calculate the value. What will be the value for the flow rate of the cooling water? 10 multiplied to 2570 minus 160 divided by 4.187 times 24 minus 13. That is, ang laki no, ng cooling water mo. In kilogram per second. That is 523.2647 kilograms per second for the conditions given on your condenser. Next one, number 6. Steam at 222 degrees Celsius with an enthalpy of 2,340.22 kilojoule per kilogram and internal energy of 2,189.6 kilojoule per kilogram is confined in a rigid container. Heat is applied until the steam becomes saturated. So, ito yung H and then ito yung U. Determine the amount of heat transferred during this process. So, ano daw yung heat na nangyari? Q is equal to, hindi natin alam, M, CB, delta T. Pwede rin namang M, CP, delta T. Confined in a rigid container. Determine the amount to be transferred during this process. Meron ka internal energy. Meron ka ring change in. So, pwede ito kasing maging delta U, and delta H. Okay? Ganun yung mangyayari dyan. Napaisip ako ah. So, dalawa yan. Yung delta U, delta H. Kapag delta U, gamitin mo yung 2604.1 minus 2189.6 kilojoule per kilogram. Kung naman delta H siya, kasi walang binigay dito na condition. So, confined in a rigid container, malamang to, that is delta H. Okay? CP, constant pressure process. Yan. So, this will become 2804.05 minus 2340.22 kilojoule per kilogram. Try natin yung dalawa. Okay. So, alpha A minus alpha B. Calculate. Yung A natin, 2604.1. Okay? B is 2189.6. So, the answer is 414 dito. So, 414.5. Next one. Calculate ulit. Palitan naman natin value. 2804.05. Tapos yung B, 2340.22. So, the answer is, ayan, 463. Hanapin yung choices kung meron mag-a-agree dyan sa dalawa. Ganun lang yun. Okay? Hanapin nyo sa choices. Malamang isa lang dyan ang tamang sagot. Okay. Next one. Steam enters the superheater of a boiler at a pressure of 25 bars and dryness factor of 0.98 and leaves at the same pressure at a temperature of 370 degrees Celsius. Calculate the heat energy supplied in the superheaters. So, Q is equal to M C delta T. Kaya lang, ang binigay sa iyo dito, meron kang dryness factor and leaves at the same temperature. So, no heat, no temperature na bago. So, superheaters, meron kang H. Hahanapin mo ngayon yung H dito with dryness factor. Ano ba yung dryness or wetness? Ang dryness factor mo, ibig sabihin, ang dryness kasi is Y. Ang wetness quality is X. Okay? Dryness factor, wetness. Okay? So, anong gagawin mo dito? Binigay na sa'yo. Binigay na sa'yo yung HF. Saan mo nakita yan? Sa 25 bar. Kinuha mo na. So, ang gagawin mo, hanapin mo na lang yung kanyang value for H dito. Sa point na papasok siya ng boiler mo. So, H entering is equal to HF plus X HFG. Binigay sa'yo HF. That is 962.11 kilojoule per kilogram. Baliktad pala ako, no? Dryness is moisture content pala ang Y parate. So, this is X, this is Y. Plus X na 0.98 multiplied to HFG. That is 1841.01 kilojoule per kilogram. So, we can solve. 962.11 plus 0.98 times 1841.01. Yan. So, the answer, entering yung boiler mo, 2766.2998 kilojoules per kilogram. Natapos na ba dyan yung calculation natin? Hindi pa. Because, in the superheaters at ito, 370. So, H. So, the heat that is supplied to your superheater is the change in the enthalpy. So, that is 3171.8 minus 2766.2998 kilojoule per kilogram. So, the answer is, minus ko na lang to, 3171.8. Okay. That is 405.5002 kilojoules per kilogram. Basic na mga tanong pag termo 2. Kasi based yan sa charting. Magcha-chart ka lang naman dyan. Okay? Next one. Ganun pa rin. Okay? Steam enters throttling calorimeter at a pressure. Pag throttling, ibig sabihin constant temperature. Constant enthalpy. Okay? At a pressure of 1.3. The calorimeter, downstream pressure, and temperature are respectively 100 MPa and 125 degrees Celsius. What is the percent moisture? O, anong gagawin mo para makuha yung percent moisture? Ganito lang, X is equal to H na ibinigay sa'yo dito. Okay? H minus HF over HFG. Yun nandito sa part na ito. Okay? So, meron ba siyang percent moisture na binigay dyan? Wala. So, H minus HF. Wala naman sa'yo binigay ditong HF. O, di gawan mo ng paraan. Di ba HF is equal to HG minus HFG? Ayan o. Baguhin mo lang to. So, X is equal to H minus HG minus HFG. Divide by HFG. O, pwede mo nang simplify to. H minus HG plus HFG over HFG. Ganun lang. So, we can calculate the value. So, H is 27. Pagpalagay natin, nahanap ko na yung value na yan sa steam table. At sa board exam, ipoprovide na sa inyo yung steam table. Hanapin nyo na lang. Minus HG na 2779.25 plus HFG na 2010.7 divide by 2010.7. So, the answer is 0.9738. That is the factor. 9738. Moisture. Percentage moisture. This is dryness. So, percentage, minus 1 ka. 1 minus 0.9738. So, yung moisture content niya is 2%. Barely. 0.02. 262. Okay? Number 9, steam flows into a turbine at a rate of 10 kg every second. And 10 kilowatts of heat are lost from the turbine. Ignoring elevation and kinetic energy effect, calculate the power output from the turbine. O, basic lang. O, work of the turbine, i-drawing mo. May work ka dito na ilabas. Tapos, meron kang heat loss. Tapos, may papasok ka ditong H1, lalabas na H2. So, energy in equal to energy out. Yung in, lahat dyan na pumasok, iisa lang. So, H1 is equal to H2 plus UR T plus work ng turbine. Nakahanapin natin yung yung work ng turbine. So, work of the turbine is equal to M H1 minus H2 minus QR sa turbine. So, M, that is 10 kilogram per second. Tapos, H1, that is 2739 minus 23.5 kilojoule per kilogram. Ngayon, minus yung heat loss na 10 kilowatts. Kilojoule per second din yan. So, the answer will be kilowatt din. So, 2739 minus 2,300.5 times 10. Ang laki naman. Minus 10. So, the output is 4375. 4375 kilowatts. Basic lang. Napaka-basic. Okay. So, yan. Number 10. Dapat to cubic meter to eh. Ito. Now, a 10 cubic meter vessel initially contains 5 cubic meter of liquid water. And 5 cubic meter of saturated vapor. So, hati-hati. At 100 kPa. Calculate the internal energy of the system. U. U is equal to. Ano ba yan? Diba? H enthalpy is equal to U plus P and V. Tama. Tama ba? Okay. Saturated vapor, ibig sabihin may VG ka dyan. And then, yung U, the change in U, binigay na dyan. Calculate the internal energy of the system. Ano ang nagbago lang? The pressure, I think, is the same. Tama, pressure is the same. Ang magbabago lang is yung VF at VG. Dito. So, HU is equal to H minus PV. So, the enthalpy, meron ka ba dyan enthalpy? Walang binigay na enthalpy. Paano ko masasolve to? So, liquid water initially contains 5 cubic meter of liquid water. Okay? Internal energy. Paano ba? Hati-hati sila eh. Okay. P volume. Saan natin kukunin yun? Sa liquid water? Or sa? Okay. Okay. So, let me get back at here Let me get back at here. Kasi meron pa akong kulang dito na hindi na ilagay. Let us proceed muna. I-reserve ko muna to. Yan. I-reserve ko muna yan. So, ito, mga steam processes. Yan, mahahabang problems. So, let us go with the fundamentals again of Thermodynamics. Ito yung mga problems na madalas lumabas sa board exam. So, continue natin. Reserve ko muna yung mga hindi ko sinolve dun sa kabila. So, a pump discharges 70 gallons per minute of water. So, meron kang Q na 70 GPM through a vertical cylinder tank. So, nakatayo yung cylinder tank mo. Okay? 7 feet in diameter. O, di 7 feet. And then, 17 feet high. Taas ah. Compute the total time required in minutes to fill the tank at half full. Kalahati lang dito. Okay. Paano kaya natin gagawin yan? What will be the volume of the water? Volume of water. Half full. O di, kalahati ng volume nitong buo. 1/2 of the total volume of the cylinder. Yan. Ano ba yung volume ng cylinder? Going back with your solid mensuration. O di, area times height. Diba? Base times height. So, ibig sabihin, pi over 4 d squared times height. Now, problema natin dyan. Hanapin natin yung time. Di ba ang Q is equal to volume divided by time? Mahanap na natin. Di ba? Ganun lang kadali yun. So, we have Q equal to volume over time. Ang hinahanap natin yung volume niya, half full. O di, this is 0.5 nung pi over 4 d squared times height divided by time. Meron tayong Q, wala tayong time. This is the one we will find. So, T equal to 0.5 times pi over 4 multiplied to d squared times h divided by Q na naka-gallons per minute. So, calculate natin. 0.5 multiplied to pi over 4. Ano yung height? Ano yung diameter? So, 7 feet. 7 feet. 7 feet. Squared. Tapos yung height niya is 17 feet. Up. Half full. Sa half full ba magbabago yung diameter? Hindi. Ano lang magbabago? Yung kanyang height. So, 17 over 2. Hindi na pala kailangan. 17 na lang lalagay natin kasi nilagay na natin half. 17 feet. Ayan o, may 0.5 ka na. Half na yan. Divided by Q. 70 gallon per minute. Ang hinahanap dito, ilan? Minute ba? In minutes, ayan. Itong gallon, meron ba tayong conversion factor for feet? Yes. You have. In 1 cubic foot, meron kang 7.481 gallon. Tama ba? Tama ba, class? Tama ba tayo dyan? Ha? Sa gallon natin? How many do you have sa gallon? Ako, nalimutan na nila, patay tayo dyan. Yari tayo. Nakalimutan na nila kung ilan ang volume. Oh. Sige. 1 gallon is equal to 7.48. Hindi. 1 cubic foot, 7.481 gallon. Or, pwede rin naman, in inches, 1728 inch cube. 1 gallon. 1 cubic foot. Yan. Okay? Yan yung mga kanyang conversion. Okay. So, cancel all the same units. Feet, feet, feet cube, gallon, gallon, akit yung minute. Okay? Yan yung hinahanap natin. So, we calculate the value. What is the value? 0.5 times pi divide by 4 times 7 squared times 17 divide by 70 divided by 7.481. So, the answer is 34 minutes. Basic, di ba? Basic. 34.9596. Yan lang po yung sagot natin. Next one. You compute the mass of oxygen gas in pounds that can be contained inside a spherical tank. Itong oxygen gas na to, hindi naman yan isa lang. Okay? That is always diatomic. So, yung atomic number niya, i-multiply mo ng 2. Okay? So, in pounds, that can be contained inside a spherical tank. O, so spherical, the volume of a sphere, that is equal to 4 over 3 pi r cube or pi over 6 d cube. Oh, yan ha, hindi nyo na alam. So, ang hinahanap natin dito is the mass. Diba? Ideal gas ang oxygen. So, we will use the ideal gas equation. PV is equal to MRT. Alam ba natin yung R? Hindi. R na oxygen, di natin alam. Pero diba, binigyan ko kayo ng R is equal to R bar over the molecular weight. Alam na. Diba? So, mass ang hinanap natin. Mass is equal to PV over RT. Simplify pa natin. Meron tayong pressure. Multiply to the volume. Yung volume dyan is the sphere. 4 over 3. Multiplied to pi r cube. Diameter ang binigay dito, di ba? Pwede rin naman. Mamaya na, baguhin ko ha. So, r bar over molecular weight. Tapos, multiply to the temperature. Pwede ko itong palitan ng pi over 6. Para madali na. P multiplied to pi over 6 d cube. O, di ba? Divided by r bar over molecular weight multiplied to the temperature. Yung r bar natin is equal to 8.3143 kilojoule per kilomole. Yan yung unit niya. Kilojoule per kilomole. Degree Kelvin. Okay? Now, we can solve for the mass. Oh, dito, tignan mo yung unit. Yung sinasabi ko, ang unit niya is in SI pero ang hinahanap niya sa final answer is in English. Ang gagawin mo, lagi kang mag-convert sa dulo. Ito muna. So, the pressure is in gauge. So, you have to add yung atmospheric. So, 225 kPa plus 101.325 kilonewton per meter squared. Multiplied to pi over 6. Multiplied to d cube. Anong d? 2.25 meters. Divide by r bar. Ganito na lang para hindi ka nalilito. 8.3143. Divide by, ano atomic number nito? Ng oxygen, that is 16 times 2. That is 32. 32. Kilojoule per kilogram, degree Kelvin. Diretso na ng ganon. Tapos, multiply mo ng temperature. It must be in absolute form then. 22.5 plus 273 degree Kelvin. Ang problema natin, nasaan niya dyan? Kilojoule is in kilonewton meter. Cancel na natin yung same unit. Kilonewton. Yung meter dito, meter. Yung Kelvin, yung meter squared. Ang natira is kilogram. Okay, aangat yung kilogram na yan. Okay, anticipate mo nga angat siya kasi nandito siya. Denominator na siya, denominator pa ulit. Kunin mo yung reciprocal. Okay, you have 2.204 pounds every 1 kilogram. As is, masosolve na natin yung value. Diba? Sa dulo ko nag-convert. So, calculate. 225 plus 101.3295 and then multiply to pi over 6 times 2.25 raised to the third power divided by 8.3143 divided by 32 kasi 16 times 2 multiplied to 22.5 plus 273. And don't forget yung kanyang conversion factor na 2.204. So the answer is 55.87. 55.87 pounds. Very basic. Okay? Very basic. Next one. An adiabatic room initially contained air at 15. To walang kamatayang adiabatic room. So, anong gagawin ko dito? MCP. MCP delta T. Yan o, nandito yan. An adiabatic room. Lagi yan. Walang kamatayang adiabatic room. O, diba? MCP. Yan. Paulit-ulit lang yan. Okay. MCB. Pag hindi nagbago. Meron din yan dito sa extras. An adiabatic. Ang ginawa naman, CV. Laging CV pala. Lagi siyang CV. Okay? An adiabatic room, laging gagamitin dito MCB delta T. Yan. Yung Q. Okay. At standard atmospheric condition o standard and temperature and pressure. After a quarter of an hour, binigyan ka ng time. Quarter of an hour. That is quarter of an hour. So, ilang minutes? 15 minutes. Nag-isip ka na lang, di ba? Todo mo na. Its temperature was increased by. Increased by, ibig sabihin nadagdagan siya. So, that is the increment in temperature, 22 Celsius degree. Calculate the total amount of heat added in HP if the dimensions of the room is. So, MCB delta T. Hindi natin alam yung M. Unahin mo natin yung M. Coming from yung room, air contained sa room na yon. O di meron tayong ideal gas law coming from PB divided by R over T. What is the R of air? That is 0.28708 kilojoule per kilogram. What is the working equation in order for you to find the heat added on the room? O the MCB delta T. Meron na tayong M. Lipat natin dito. Okay? Isang calculation na lang. So, Q is equal to, ano yung M? That is PV divided by R T multiplied to CV delta T. Ayan na yun. So, we calculate. Q is equal to PV. The pressure. The pressure is atmospheric at condition. So, that is 101.325 kilonewton per meter squared. As is. The volume of the room. Length times width times height lang yan. 7.5 times 10.5 times 12.5. Anong unit? Meter cube na agad. Divided by R of air. 0.28708 kilojoule per kilogram degree Kelvin. Multiply to the absolute temperature. The absolute temperature, that is 15 plus 273 degree Kelvin. Multiplied to the CB. CB of air. Ayan na, dyan tayo magkakatalo. CB of air. That is 0.171 BTU per pound degree Rankine. That is equal to 0.7186 kilojoule per kilogram degree Kelvin. CP naman, that is 0.24 BTU per pound degree Rankine. That is equal to 1.0062 kilojoules per kilogram degree Kelvin. Ang ginagawa sa board exam, ino-omit na itong decimal places. Okay? Ginagawa na lang nilang 1. So, CV, 0.7186 kilojoule per kilogram degree Kelvin. And then, multiply mo sa change in temperature, that is 22 Celsius degree. Mag-cancel all the same units. Anong inihingi niya dyan? Calculate the total amount of heat added in HP. Tignan muna natin kung anong magiging unit. Cancel all the same units. Kilojoule per kilogram, degree Kelvin. Yan. Degree Kelvin. Eto. Yung meter. Meter. Ang problema. Mass. May seconds ba dito? Wala tayong time. O, i-divide mo ng time. Problema ba yun? 15 minutes. 'Di ba? Divide by time. O, dagdag mo yung time. 'Di ba? Hindi pwedeng wala kang time. So, yung time mo is 1 over the time, 15 minutes. Tapos, 15 minutes yan, di ba? Gawin mo seconds. Ilan seconds? 1 minute per 60 seconds. Okay. Mababago pa yan. I-divide mo na ngayon ng buo. Ang lalabas dyan is kilowatt. So, 0.746 kilowatt every HP. Try mo isolve. Okay? Okay. Isa-isa. Ito muna sa taas. Taas muna tayo, ha? Follow my lead. 101.325 times 7.5 times 10.5 times 12.5. Divide by 0.28708. Tapos multiplied to 15 plus 273. Kasya yan sa calculator. Trust me. Times 0.7186 times 22. Okay. Divide by 15 times 60. Times mo pa ng, pwede na yan pala. Divide mo na lang ng 0.746. So, ilang HP? 28.41 HP. Ganun lang kadali yun. Isang computation lang. Di ba? Pinagsama-sama ko. That is the technique na ini-employ ko. Even when I am a student. Para isahan na lang. Hindi naman kukumpute ako ng mass, kukumpute ko yung Q, kumpute ko yung time, blah, 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 blah. Ganun. Isang pindutan, isang input, solve mo kagad yung final answer. Next one. A compressed air is confined in a cylindrical tank, 1.5 meters in diameter. So, cylinder na naman. Volume of cylinder. D pi over 4 d squared times height. It is to be maintained at a temperature of 11.5 Celsius degrees and the pressure gauge of 11.5 bars. Calculate the required length of the tank in feet if the maximum mass of the air is 211.5 kg. Paulit-ulit na lang eh. Diba? That is PV is equal to MRT. Nakakasawa naman. Yung volume mo nga lang, papalitan mo ng pi over 4 d squared h. Ang hinahanap is h. Diba? So, palitan ko dito. Pressure multiplied to pi over 4 d squared times height equal to MRT. Ang hinahanap natin is height. So, height na lang itira natin sa dulo. That is equal to cross multiply. So, 4 MRT divide by pi times p d squared. Meron na tayong formula for height. Now, we can solve for the problem. 4 times the mass na 211.5. Tama ba? Kilograms. Kg. Tapos, anong hinahanap? In feet. Kaya lang ito naka-meters. Okay lang yan. Sa dulo ka na mag-change. R ng air. Air ba yan? Air. R of air is 0.28708 kilojoule per kilogram degree Kelvin. The temperature, 11.5 plus 273 degree Kelvin. Divide by pi times pressure, naka-gauge, kailangan absolute, 11.5 bar. So, 11.5 bar. I-multiply ko na to ng 1 bar, 100 kPa plus 101.325 kilonewton per meter squared. Ganon din yan. Pares lang yan. Times diameter na 1.5 meters squared. So, anong hinahanap? In feet. Cancel muna natin yung same units. Kilogram, kilogram, Kelvin, Kelvin. Itong kPa, okay? Kilonewton, okay? Kasi ito kilonewton, meter. Ang matitira lang meter. Meter squared. Yan, meter squared. Ang natira is meter lang. So, i-multiply ko na ng conversion factor ng meter to feet. You have 3.28 feet every 1 meter. Cancel na to. Cancel na rin to. So, ang natira is feet. So, we can calculate na. Bilis lang, di ba? So, 4 times 211.5 times 0.28708 multiplied to 11.5 plus 273 times 3.28. Divide by pi times 11.5 times 100 plus 101.32 times 1.5 square the value. The answer is the height in feet. 25.623 feet. Okay. Next one. 28 kilograms of air undergoes isobaric process. So, isobaric, pressure is constant. At an initial pressure of, at temperature of 28, a total of 280 kilocalories of heat have been added per second. So, ibig sabihin, meron tayong Q. That is mCp delta T. Calculate the work non-flow in kilowatts. Ano ba ang work non-flow dito? The work non-flow for isobaric process is equal to P times B2 minus B1. The work non-flow in kilowatts. Pwede rin naman kasing ganito yan. Yung Q mo is equal to H plus work steady flow. Kapag ganito, wala namang work non-flow dito. Okay? 0 ang work steady flow dito, kaya naging Q is equal to H. Okay? Ganun lang yan. So, V2 and V1. CP delta T. Okay? 28 delta T. Okay, alam ko na. So, kukunin mo muna yon T2 dito. Yan. So, Q is equal to M, C, P, excuse me, CP, tapos T2 minus T1. Hanapin mo dito si T2. T2 is equal to Q divided by M, CP, plus T1. Yan. So, T2 is equal to Q. Ilan kilocalories yan? 280 kilocalories. 280 kcal. Divide by CP of air. That is 1.0062 kilojoule per kilogram. Degree Kelvin. Kailangan mo i-change to. You have 4.187 kilojoule per 1 kilocalorie. Tapos, add ka dito ng T1. T1 should be in absolute dapat to eh. 28 plus 273. Ayan. Degree Kelvin ang lalabas yan. Tapos, overall, minusan mo ng 273 para maging degree Celsius to 22. Yan. Or pwede na rin, degree Kelvin na rin. Any way you prefer it. So, 280 times 4.187 divide by 1.0062 plus 28 plus 273. Yan. 1466 point. 1466.1362 degree Kelvin. Ganun. Okay? So, that is T2. Anong hinahanap? Work non-flow. Wala tayong V2 and V1. Tama ba? Meron tayong pressure. Hanapin natin si pressure. Equal yung pressure. Okay. Paano ba to? Pwedeng ganito. P tapos V2 minus P V1. Equal yung P. Di ba? So, ano ba ito? Tandaan nyo that PV is equal to M R T1 minus M R T2. So, pwede pa lang ang work non-flow is equal to MR. Di naman magbabago yung mass eh. T2 minus T1. Diba? Magic. Diba? MR T. So, the mass now is 28. Tapos yung kanyang work non-flow is equal to mass 28 kilograms. Yung R ng air, 0.287. 08 kilojoule per kilogram. Degree Kelvin. The change in temperature. Kilogram per second to ha. Tapos, T2, that is 1466.1362 minus 28 plus 273. So, 1, 1, 0, 1, 301 degree Kelvin. So, cancel all the same units. Kilogram, kilogram, kilojoule per second, that is in kilowatt na. So, 28 times 0.28708 times 1466.1362 minus 301. So, the answer is 9365 kilowatts. So, let me take a 5-minute break. Yan, meron ako naging discrepancy dito. Hindi ko nasama yung mass. Hindi ko nakita. Yan. 28 kilograms. Tanggalin mo na muna yung seconds. So, recalculate natin. Okay? Recalculate muna natin. Hindi ko nasama yung mass eh. Namalikmata na ako. Dire-diretso na yung solving ko eh. So, 280 times 4.187 divide by 1.0062 times 28. Kaya pala ang laki. Plus 301. Ayan. 342 lang. Kaya ang laki. Nagtataka ko eh. So, 342. 342.612. Ayan. Minus 301 times 28 times 0.28708. Yan. So, 334. 334.49. Okay, so let's proceed with the final 4 problems. Pahinga lang ako. Pagod. So, 4. Compute the mass of oxygen. So, inulit na naman to. Okay, let me eliminate na lang to. Inulit na siya. Last 3 na lang pala. A Carnot engine requires 35 kilojoules per second from a hot source. So, a hot source, ibig sabihin, might be that is QA. QA. So, 35 kilojoule per second. The engine produces 15 kilowatts of power. So, yan yung work net. 15 kilowatts. And the temperature of the sink is 25 degrees Celsius. What is the temperature of the hot source in Celsius degrees? So, ganito yan. Diba meron tayong work net over QA? Diba pag Carnot, pwede rin natin gamitin yung hot side and then the cold side niya. So, TL over TH. Pwede nating malaman. Ito ang hinanap natin. Hindi. Ito yung hinanap natin, TH. Reform natin. Cross multiply. So, work net over QA equal to TH minus TL over. Hindi, kahit di na yan. Dito na lang. Ilipat ko na dito sa kabila. Okay? Huwag natin pahirapan sarili natin. Lipat ko siya dito. Lipat ko siya dito. Huwag na tayo mag-cross multiply. Okay? So, TL over TH is equal to 1 minus work net over QA. Pwede na yan. So, ang hinanap natin, TH. So, dito na tayo mag-cross multiply. So, TH will be equal to TL over 1 minus work net over QA. Simplified na. So, TL natin is 25. Absolute dapat. 25 plus 273. Degree Kelvin to. Divide by 1 minus work net is 15 kilowatts. 15 kilojoule every second pa rin naman yon. Divide by 35 kilojoule per second. Then, dapat ang gusto natin makuha dito in Celsius degree. O di lahat ng ito, minusan natin ng 273. Para ang lalabas dyan is degree Celsius. So, we calculate. 25 plus 273. 1 minus 15 divide by 35. And then, buo, minus natin ng 273. So, the temperature is at 248.5 degrees Celsius. Yan. Next, last two. So, the deepest ocean in the Philippines is measured at approximately 10 kilometers. So mula Antipolo hanggang Cubao. Compute the pressure at the deepest part of the ocean in MPa if the average specific gravity of the ocean is 1.2. Use a standard sea level pressure. So the pressure is measured using the product of your specific weight of the water or the fluid multiplied to the height or the depth. Now, yung specific weight natin is simply yung Sg of the fluid multiplied to the specific weight of the water. Okay? H2O. Ano ba specific weight ng water? That is 9.81 kilonewton per cubic meter. Pwede rin naman sa English units, that is 62.4 kilo tuloy. 62.4 pound per cubic feet. Yan. Pwede natin ma-solve. Okay? Ang hinahanap dyan is the pressure at the deepest part of the ocean. Basic na yan. So, Sg ng fluid times yung density ng water times height, yung depth. So, SG of the fluid is 1.2 multiplied to specific weight 9.81 kilonewton per cubic meter multiplied to the height, which is 10 kilometer. Times ko na lang, 1 kilometer, 1,000 meters. Yung depth, ano bang inihingi dyan? MPa. O sige, pwede na yan. Kilonewton meter. O di, pwedeng 1 MPa every 1,000 kilonewton per meter squared. Okay, calculate. So, 1.2 times 9.81 times 10. Cancel mo na yung 1,000. Okay na yun. So, the pressure at the bottom of that ocean is 117.72 MPa. Very basic lang. And for the last one, yan. Ito medyo mahaba to eh. A cylindrical drum, 4 inches in diameter and 4 feet long, contained pure oxygen gas at 140 psia and 140 degrees Fahrenheit. This is condition 1. After some of the oxygen gas was used, the pressure was reduced to, so this is 2. Yang conditions na yan. Now you compute the volume in cubic feet. Would the used oxygen gas can occupy at 14 psia and 40 degrees Fahrenheit. Yan ay remaining. Okay. We have a total mass 1 and then meron tayong mass 2. What will be mass 3? So the resultant, M3 is equal to M1 minus M2. Check, check, and check. Tandaan nyo that oxygen is an ideal gas. So we will use PV is equal to MRT. Do we know? At each points, do we know the following masses? No. Tama ba ako? Hindi natin alam. Okay? Pero ang inihingi kasi sa dulo, hindi naman yung mass, but V3. Sa atin kukunin si V3. O di dito, sa conditions na meron tayo sa 3. So, MRT3 divide by M3 divide by T3. Meron tayong pressure, meron tayong temperature. Unahin muna natin si M1 and M2. So, M1 as pressure 1, volume 1 over R temperature 1. Now, yung volume naman yan, cylindrical, di ba? So, pressure is 140 psi, 140 pound per inch squared. Tapos, yung volume is pi over 4 d squared. Diameter is 4 inches. 4 over 12 para maging feet na. Squared. Times 4 feet long. Divide by R. R of air, 53.34. Feet pound per pound. Degree Rankine. Ngayon, pag may nakita kang PSI dito, multiply mo kagad to. Okay, multiply mo kagad yung inch dyan. So, dapat nandito yung inch. Para maging feet. Okay, nasaan yung PSI? Nasa taas. Pwedeng sa taas ka na mag-multiply ng conversion factor niyan. That 144 inch squared per 1 foot squared. Now, i-multiply mo to ng temperature, which is 140 plus 460 degrees Fahrenheit. Okay, makuha mo ng M1. Yung M2, yung volume ng gas, yun pa rin naman yung inoccupy niya eh. Yun pa rin naman yung inoccupy niya. Doon sa 2. Okay? Yun pa rin naman yung inoccupy niya na amount of container. Dito ang tinatanong yung volume na na-spend mo. Volume of the gas that you spent during the operation. So, P2, V2 over R, T2. Now, this is 0.2 na. So, 104 pound per inch squared times pi over 4. Same pa rin ang inoccupy niyang volume. So, 4 over 12 feet. Square natin to. Times 4 feet. Times 144 inch squared divided by 1 foot squared. Divided by 53.34 feet pound per pound degree Rankine. Multiply 2. Okay? 0.2, 104. 104 plus 460 degrees Rankine. O, cancel all the same units. Anong lalabas dyan? Pounds dapat. Inch squared, yung pound, feet. Rankine. Okay? Feet squared, inch squared. Yung feet na nandito natitira. Ang natira na lang is pounds. Ganon din dito. Ayan. So, equal natin. Ayan. Again, calculate. 140 times pi over 4 times 4 over 12 squared times 4 times 144 divided by 53.34 times 140 plus 460. Store natin yung value niya kay A. This will become value at A. Ayan. Sa B naman, palitan lang natin yung mga values dito ng 104. Para dire-diretso yung ating solving. So, the answer is at B. Okay. Store natin yung value niya kay B. Now, we have yung M1 and M2. So, we can solve for M3. M3 is M1 minus M2. Or, yung sinolve natin na values at A minus value at B. So, we can solve for the value niyan. Ano ba yung M3? Recall natin, alpha A minus alpha B. O, the answer is 0.046. Kagandahan dyan, hindi ka na mag-round off. Pero ito, in the sense of calculation, nag-round off muna ako. Pounds. That is the pound. Now, you will find yung volume at 3. Iba na yung magiging container niya kasi it can occupy na daw yung 14 PSI and 40 degrees Fahrenheit. Iba na yung volume. Nasa labas na siya. Okay? So, M3, that is 0.046115 pounds multiplied to MRT, 53.34 feet pound per pound degree Rankine. Multiplied to temperature. Anong temperature binigay dyan? 40 degrees Fahrenheit plus mo ng 460 degrees Rankine. Divided by P, yung pressure niya. The pressure is 14 PSI. Pound per inch squared. Now, i-multiply mo na ito ng conversion factor na 144 inch squared per 1 foot squared. So, the volume will be 0.04615 times 53.34 times 40, 460, bali 500 na yan. Divide by 14 times 0.144. Anong hinahanap na unit? Cubic feet. Ang lalabas dito, cubic feet dapat. Pound, 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 inch squared, feet, degree Rankine. So, feet cube nga ang lumabas. So, the answer is 610. Uy, 0.144, kaya pala. 0.61 cubic foot of the gas. So, that is for thermodynamics. I hope may napulot kayong bago. And I hope mag-review pa kayo na mag-review para madagdagan pa yung idea nyo. Okay? See you next meeting. Have a nice day.